Hey there, 4.8 word problems with trig.
Yes, indeed. And by the way, it might help if you just draw out the triangle on every one of these puppies.
Absolutely. Draw out a triangle, and then it also just takes some getting used to. I don't know what that random mark was for, but I thought I'd get rid of it.
There's another one right
what?
there.
There's another one? Okay. It helps if you will draw a picture, but also you just have to kind of get used to the word problems, get used to the way they phrase it. Yeah, and so the more you do, the better you'll get, and the better prepared you'll be for, say, a test where there might be some word problems.
Hey, there might be some on the next test, maybe?
Yes, maybe.
Okay.
Perhaps. So the first thing we want to talk about, though, is a little thing called angle, well, two things, angle of elevation and angle of depression. So if I've got a little, like, stick figure, need to draw, a little stick figure guy here. Okay, and this is his perspective, is if he looks forward,
line of sight.
If he looks forward, that's this line right here. Whenever we talk about an angle of elevation, elevation is up, so this would be his angle of elevation.
So if he's looking straight and then he looks up, what angle right here, that's the elevation part.
Right, and then if he's looking forward but then he looks down, say he's at the top of a building and he's looking down at something, then we call that the angle of depression. Think about if you're depressed, you're sad and right low, here. Right? So, or when you depress something, you're pushing it down.
Now, a common mistake is to put that angle of depression on the other side there, right in there.
Right here?
Yeah.
It's not here.
It's not there.
But what tends to happen is we tend to end up drawing a triangle here.
Right.
A right triangle. And so if they give us the angle of depression, let's say that angle right there is 20 degrees. Well, it just so happens that that means this one is. Because we've got a parallel line situation. These are alternate interior
transversal.
Angles. Yeah, so that's a geometry thing where, and you can, if you don't remember that, or it doesn't occur to you, you can work it out by saying, well, this is a 90-degree angle. If this is 20, this is 70, which leaves 20 for that one.
Right.
But that right there is going to be probably the most helpful things we can give you as far as instruction in general goes for this stuff. So,
and then you just got to practice, like Mrs. Stevenson said. Practice these puppies.
Right. So we're going to give you a few examples of how to set things up and things like that. So example 1, the angle of depression from a buoy from the top of Barnegat Bay Lighthouse 130 feet above the surface of the water is 6 degrees. Find the distance x from the base of the lighthouse to the buoy.
We've got enough information there to fill out a triangle, believe it or not.
Yeah, we've got a buoy up here, up at the top, and so it gives us the angle of depression. So the buoy, if it was able to look out, it would look out straight, and then we would find the angle of depression.
I feel like maybe from the top of the lighthouse to a buoy. Maybe that's worded. Maybe it's got a funny wordage.
Oh, I see what you're saying.
Because, buoys are going to not be on top of lighthouses.
So we've got
Let's go from lighthouse to buoy.
All right.
The angle of depression from a buoy to the top of Barnegat Bay Lighthouse.
Buoy.
Oh, buoy.
The lighthouse, if you... look out, and then we've got an angle of depression.
Right there, yes. I think yes.
Okay,
yes. All
so
right.
they're telling us that this angle right here is 2 degrees, and they want us to find...
6 degrees.
Oh, where did I get 2?
I don't know. Drugs?
No, that's not where I got it
right.
from. Okay, find the distance x from the base of the lighthouse to the buoy. So we can set up a right triangle. Actually, one of 2 different ways. We could actually... Ooh, that didn't really match up. We could actually set one up this way instead if we wanted to, whichever. I'm sorry. There we go. Right triangle. So if this is 6 degrees, that means that this angle is also 6 degrees. By what we said earlier in our instruction, the distance x from the base of the lighthouse to the buoy, and the lighthouse is 130 feet.
So what trig function relates an angle and an opposite and adjacent?
That would be tangent.
I agree.
Tangent of 6 degrees equals the opposite side, which is 130, over the adjacent side, which is x. So to solve this, we do...
Solve it for x.
cross multiplication kind of thing. Divide by tangent on both sides. Hey, I don't think we have a calculator over here.
Hold on, I've got a calculator.
Make sure you're in degree mode because guess what? 6 degrees, that's in degrees. So most of the time for word problems like this, we will be in degree mode. For whatever reason, we don't tend to talk about radians whenever we're like, I'm going to look up 5 radians.
5 radians from 5 pi over 2 radians.
Right, that doesn't tend to happen.
So tan of 6 degrees. 6 degrees of Kevin Bacon.
That's a different situation. Hurry it up.
Okay, 130 divided by. I get a 1,236.87 feet.
All right, so that's the distance from the buoy to the lighthouse.
Does that make sense?
It does, because that's a really small angle, so x should be a lot bigger than 130.
That's what I think, yeah.
So I think that
most of the time
works.
you can ask yourself, does this, if we would have gotten a number like 3, that's not going to work.
No, and so if you had put in radians, you probably would have gotten some crazy number, kind of like 3.
Or negative.
Or negative, yeah.
Right.
And so for these distances, this is distance, not displacement.
Right.
So we shouldn't be getting negative answers.
Correct.
Example 2. From the top of a 100-foot building, a man observes a car moving toward the building. If the angle of the depression of the car changes from 22 degrees to 46 degrees during the period of observation, how far did the car travel? This is a fantastic problem. We have got a
like
building.
this problem, yeah.
Okay.
Draw the building.
Okay.
Make it a cool one.
Okay.
Put some windows on it and stuff.
I'm not going to get that carried away, but here's our building. And there is a guy on top of the building. So, hello, Mr. On top of building man. It's a 100-foot building, so this is 100 feet tall. And he's looking out. So, we're going to actually call the top of the building.
We'll say he's laying down on top of the building, because
Yeah,
we don't know how tall
he's
it
probably
is.
laying down on the
he's
top of the
eyeballing
building.
it, yeah.
So this right here is if he looks straight. So the angle of depression, he's actually got 2 things going on. He at one point looks out. At one point looks out and it's like.
That's drawing right to your face.
Hang on, I'm gonna try something. First, let's do the ground. And yeah.
Oh.
Hello, face.
Hello, face.
Okay, so he looks out at first, and there is a car
right there,
where this angle here is 22 degrees.
That angle.
That angle. The
right.
angle of depression.
The angle of depression, right.
Then he looks again, and the car has moved forward because it's apparently driving, and now it's going to be 46 degrees. So let's say something like that. And this isn't a very good scale because I ran out of room because our faces go down there. So this angle is 46 degrees. So what we've got is we've got 2 different triangles here. Right?
Shut the front door.
It wants us to figure out how far the car traveled, which is this right here. I'm going to call it Y. How far did the car travel? It started over here on the right and it ended right here on the left. And so what we have to do is we have to figure out 2 things. Or we're using 2 things,
We're going to use
right?
2 things, right.
Right? Because we can figure out, since this is a right triangle, we can figure out what this x is. And then...
Big X.
Yeah, we
X
can
plus
use
Y.
we can figure out what x plus y is using a different right triangle. And then come up with what y is. So this 22 degrees goes here also in our triangle, and the 46 degrees goes here also. So we can say tangent of 46 degrees is 100 over x. Okay, and then we can also talk about tangent of 22 degrees is 100 over this whole long side, which is going to be x plus y. Okay, so did you figure out what x was?
I did. X is 94.569. 94.569. Always 3 decimal places.
and this is feet. And so, and keep in mind here, this is 94.569 feet for x, and we're going to end up plugging that in here. And the way he solved this is we have to cross multiply. We end up with 100 divided by tangent of 46. We put that in right here for x, and so we're going to cross multiply here and have 94.569, which is x, plus y
times tangent
22 equals 100. Well, we could distribute, or we could go ahead and divide by tangent 22. And then that's 94.569 plus y equals whatever that is. 100 divided by tangent 22.
247.509.
And then we would subtract this number from each side.
I get 152.939 feet. Or 152.94, either way.
152.9.
You could do 94 because it's going to round.
Okay. Now the thing is depending on how you round on this and how much you round, you can end up with slightly different answers.
But you should be really close to 152.9.
Right. Right. Really close in there, and we could, if we tried really hard, end up not rounding at all. If you did 100 divided by tangent 22, and you had this number in your calculator, and then you subtracted from that this number, but how we got that was 100 divided by tangent 46.
If you left that in there.
Yeah, if you left that in there. And so you could end up not rounding if you were careful. But in case you get slightly different numbers, it's probably a rounding thing.
So now we found x, and at the end we found y. So the car traveled 152.94 feet.
Right. And our answer for x made sense that this is 94.569. This isn't a very good scale, but if this is a 46-degree angle, these should be really close in number.
Right.
And they were.
They were.
Okay, but this should be.
It's going to make it different.
This is not. Yeah, this is not to scale. This should have been a lot farther out there because 22 and 46 should have been a lot farther apart.
Right.
So, okay. All right, we have example 3 here. And we've got a large helium-filled penguin.
Pedro
the penguin, maybe, is moored at the beginning of a parade route, awaiting the start of the parade. I guess that means it's sitting at the beginning.
Sitting there, waiting to be used.
2 cables attached to the underside of the penguin make angles of 48 degrees and 40 degrees with the ground and are in the same plane as a perpendicular line from the ground. If the cables are attached to the ground 10 feet from each other, how high above the ground is the penguin? So let's see if...
can you draw the picture?
Let's see if I can. So we've got the ground down here, and we've got cables attached to the penguin, because this is like a balloon in a parade, and so there's cables going like this. Right? That's what we're saying?
Yep.
Attaching it to the ground. The cables are 10 feet apart. Now, I'm a little iffy on these angles. Maybe we'll have to talk about... Oh, what
is that? What have you done?
Sorry. There's a button on the side of the pen that sometimes I accidentally press.
Oh, okay.
So, what's going on?
I think, we got a 48 degree and 40 degree angle with the ground. So I think down here on the ground, right there, yes.
Okay.
40 and
it really doesn't matter which one we label 48 and which one we label 40.
And then we're perpendicular to the ground with that right
in
there.
In the middle?
Yep, right there, yep. I believe that would be...
Well, that's good, because that would give us 2 right triangles.
Oh, man, right triangles. Whew, That's
good, because that's all we know how to really deal with right now. But that'll change soon.
What?
Spoiler, sorry. Okay, so we need how high above the ground is the penguin, which is this. Well, we don't know. This is 10 feet all the way across, but we don't know what this or this length, what these lengths are.
Something.
There's something, but we don't know what they are. So how are we going to go about this?
Well, would we have like A plus B equals 10?
Yeah. Sounds reasonable. A plus B equals 10. If we knew what A and B were, we could say that tangent of 48 degrees equals x over A, and we could say that tangent of 40 degrees equals x over B.
Wait a second. I see two x's there.
Because they share that.
So could we solve for x and set equal?
Okay. A tangent 48 degrees equals x. B tangent 40 degrees equals x. So we set them equal to each other. A tangent 48 equals B tangent 40. Okay, that's some progress. We know that A plus B equals 10. So if we solve for one of those, we can plug in. If A equals 10 minus B, then we put 10 minus B here, tangent 48 equals B tangent 40. All right, now we got to get B by itself. So
Gonna have to distribute. So we got 10 tan 48 minus B tan 48. You got enough room to write there? Okay, Steve. It's over there on the edges.
We'll make it work. Then we need to get the B's on one side, so we would add
B tan
48 over to this side. And then we could factor out a B. We could actually figure out what the tangents are and use decimals, but in some ways to me that's like harder to do it that way.
Well, you got a lot of stuff that you're chasing around.
Right.
But it's easier if we can work with one set of numbers at the end.
Yeah, so 10 tan 48 equals, I'm going to take the B out, and that gives me tangent of 40 plus tangent of 48. Sorry, I got a little bit of room issue. So we solve for B, which means that we divide by this tangent 40 plus tangent 48 over this side. So 10 tan 48 over tan.
Oops, hold on, I forgot a multiply symbol here.
40 plus tan 48.
Tan 40 plus 48?
Yeah. Boy, I made that plus sign look really awful.
So we're using the algebra with our trig.
Yeah, because they kind of go together.
So I get, for B, I get 5.969, which makes sense. That's what I said.
Yeah, B is 5.696. It
Right.
has to be something less than 10. Okay, so what we can do is we can plug that into tan 40 equals x over B so that we can solve for x, which is what we wanted, which is the height. So we're going to plug this in right here and have tangent 40 degrees equals.
Now, on my
X
calculator, I'm going to
over-
go ahead and carry over my answer that I had, so this should be a pretty
Right, 'cause
exacting number.
we just need to take that 5.696 decimal and multiply it by tangent of 40. So x equals 4.779 or 4.780? 4.779 feet.
And ask yourself, does that make sense?
Makes sense to me. If we're in the
sounds like something that could work.
Because we're in the 40s here, and so it's got to be like if the B here was 5.696.
So it should be similar.
They should be pretty close, so it
Yeah.
makes sense to me. From the last example, code word, Pedro the penguin. I have a penguin in my room named Pedro. He's Christmassy, and thank you, Laura, for getting me Pedro the penguin. Mr. Hazelwood's jelly.
Totes jelly.
He would like a Pedro the penguin too.
Please.
So, example 4. A U.S. Coast Guard patrol boat leaves Port Cleveland and averages 35 knots, which we decided earlier the first time that we did this problem.
It's going to be a
and
speed
screwed it
thing.
up. That it's nautical miles per hour. That's what knots mean. for 2 hours on a course of 53 degrees, and then 3 hours on a course of 143 degrees.
Right.
What is the boat's bearing and distance from Port Cleveland? First off, bearing or course, when you see that, that is not talking about normal trig angles. That's where we draw our x and our y axis, or actually it's more like we're drawing a compass where
Right. It's totally a compass.
North is 0 degrees, and then our angle goes this direction for positive values. The other way that we might see it at some point is they can tell us, well, it's going north 35 degrees east or something like that. And the way you draw that angle is you have your compass, northeast, southwest, and you start at north, since that's the first thing they told us. You draw a 35-degree angle, and then you draw your line. Okay.
In the east direction.
Yeah, you go the
east
direction. So, and that's a 35-degree angle because it's 35 degrees to the east of north. So those might come up that second way. But course here, they say a course, so we have to draw it that way. So I'm gonna try really hard to draw a fabulous picture here of what's going on.
And it's important to kind of try and draw this as well as you can. Now, it is going to be tricky the first few times, but hang in there and just practice what you're doing here, because that's the key to all of this.
This is going to be Port Cleveland right here, and they tell us
at the origin, right?
Yeah, they tell us that it's a course of 53 degrees. So from north, we need to go 53 degrees and draw our line. Look at that line.
That is a great line. Wow.
Okay, and then the boat turns and is at a bearing of 143 degrees. So we draw a new x and y axis.
Because we need to get the bearing correct here. And this is not a time for just guesswork.
The other thing that this allows us to do is it allows us to look at parallel lines, because I don't know if you know this, but if I draw a line going from north to south at one spot and I draw a line going from north to south at another one, those are parallel lines.
Those look pretty close.
They're pretty close because I'm freehanding kind of. But okay, so 143 degrees. Well, how far is 143 degrees? It's 90 plus 53.
That's also a pretty good drawing of a line. And this time they're going to go for 3 hours in that direction. So they're going
so that's
another
why that
hour.
line's longer.
Yeah.
And so this is 90 plus 53, which gives us the 143. So what we can do is we can fill in some angles here, because we've got the parallel lines and stuff. Like if this is 53 degrees, then this has to be 53 degrees. And this would in turn be 37. This would be 37. And then we could fill in that this has to be 37. Well, basically what's happening is this is going to be 90
Look at there,
degrees.
a 90-degree angle.
90-degree angle.
Wow, that's great, because we're working with 90-degree right triangles.
Right, so let's finish off this triangle right here.
Let's do. Oh my goodness.
And what we're looking for is how long is this side,
Yep.
and we're also looking for the bearing that the ship is going. So they told us they travel 35 knots for 2 hours.
That's a big fat 70.
That is a distance of 70 nautical miles.
70 nautical miles.
3 hours at the same speed. 3 times 35 is
105, I believe.
105.
If memory serves correct.
Yes, and so we actually we drew this stuff out. We don't know this angle, and we don't actually know this angle inside our triangle.
The whole angle.
Okay, those are unknowns to us. But I don't know if you know this, but when we have two sides of a right triangle, Pythagorean theorem gives us the third side.
Shut the front door.
I know. It's
good
crazy.
Old Pythagoras. If it wouldn't have been for him, we couldn't solve this puppy.
Yeah.
So let's give it up for Pythagoras.
Degrees? No.
We are not working with degrees, K.
70 squared plus 105
I'm on it right now.
Square root it, and that gives us this distance x.
126.194.
And that is, we said knots was nautical miles per hour, which means our distances were in nautical miles. I don't actually know if this is the abbreviation for nautical miles, but we're just going to go with it.
I think that's Newton meters.
For right now, it's nautical miles.
Okay.
But you're probably right. Okay, we need to find that angle. So I'm going to try to do a little bit of strategic erasing here.
Strategic erasures. Good luck with that. Wow, that's great. That's some strategery.
Okay, because I felt like that was going to kind of get in our way.
Yeah, it's had potential because we need to work right there.
Whoops. Okay, we need to figure out...
The whole angle from blue to pink, all the way around to pink.
Do we need blue to pink?
No, not that blue, the other blue. Light blue.
Light blue?
Light blue, that blue.
This right here?
Yeah,
That's
we
the
need
angle?
we need to figure that angle out. Because whatever that is, we're going to add to 53 to get our bearing.
Why?
So I'm thinking...
Oh, okay. Yeah, 53 plus this angle.
Yeah, gets our bearing.
Duh. Okay.
Yeah. Yeah.
So this is the angle we're trying to find.
Work with me here, KC.
I'm
Work
sorry.
with me.
I'm so sorry. Okay, we know all the sides. So, but we originally knew opposite and adjacent. So just in case we screwed this up, we should use tangent. We don't know the angle. Opposite is 105 over adjacent, which is 70. Hey, if you don't know the angle, you use inverse tangent. Like that,
always finds the angle.
You got to do that. Inverse tangent to find the angle. That angle is...
Oh, it gave it to me in radians. 0.983.
Well, let's find it in
times
degrees.
180 divide by pi. 56.3031. 56.31.
56.31.
Rounded to 3 decimal places. It rounds on that 3rd decimal place there.
All right, so 53 plus 56.31, that means that our bearing...
72.
What?
Sound right?
53 plus 56.
Oh, plus 53. 109.32. Again, that's rounding at the 3rd decimal place. It rounds to a 32. 31. 0.31.
Okay.
That's what I meant to say.
There we go. Problem done. Don't forget the code word. If you really want to do this example, it's example 5 in your book. Check it out. Simple harmonic motion. There will not be a problem like this on the assignment.
What?
So, we're not going to do it in video.